Hi there, I'm often asked to recommend multimeters, and so I decided to buy some models and test them. Here's the first one, the Crenova MS8233D, in a rather nice case with a reassuring safety test sticker. I looked for affordable meters with more than 2000 count displays, do volts and current, and are not smart, because for sensitive electronics, smart still has some issues. The meter is surprisingly small and, unusually, comes with two sets of leads. One seems to be the normal set for probes, but this has some serious alligator clips instead. That's quite handy. You can buy this meter from many places. Here is Amazon, just as an example, because I did not buy mine from there. Prices vary somewhat, about £25 or $30, but you may get it cheaper. Just make sure you get the 6000 count model, because I think there's an earlier one with less. Feature-wise, the Crenova is reasonably well equipped. The only thing I miss a bit are a dedicated millivolt range, a bar graph display, a rel button, and maybe a temperature range, in that order. The function key selects the additional functions on some of the settings. It's interesting, some are not indicated on the selector switch, and you have to know that in AC volts you can also see frequency. And in the current ranges, it switches between DC and AC and frequency. It is useful to have the option of manual ranging, for example in this case where voltage is fluctuating and it's hard to see what's going on with the continuing auto ranging. Setting suitable manual range makes the display much easier to interpret. Another case for manual range is measuring lots of resistors of roughly the same value, because it avoids tedious auto ranging delays. As with many meters, hold serves two functions. Short presses do hold, while long presses turn the backlight on or off. The backlight stops automatically after 30 seconds. I won't bore you with my verification of accuracy in the various ranges, just the results. As always, you will see the dramatic increase of error on small values. I explain it here for DC volts, but the same applies to the other functions. The lowest range of the meter, in this case 600 millivolts, which for a 6000 count meter means the least significant digit is 0.1 millivolt. Naturally, you can't measure anything less than that, but even above this threshold, the display is basically a single digits. With very few digits to show, this is where the digits part of the accuracy spec hits you mercilessly. This table shows what is happening here. If the input to the meter is a true 1 millivolt, an ideal meter would show that. Unfortunately, ideal meters do not exist. The error caused by the meter is usually expressed in a percentage and a digits part, each contributing to the overall error. The spec says plus minus 0.5% plus 7 digits, so the displayed value can be wrong by plus minus 7 digits, which means in this case plus minus 0.7 millivolts. If what you are measuring is, say, a true 1 millivolt, the display could show 1.7 millivolts or 0.3 millivolts and still be in spec. This amounts to a whopping 70% error, which is still in spec. As the input and thereby the number on the display increases, the amount the digits error adds to the normal accuracy of 0.5% diminishes. At 10 millivolts, the total drops to 8%. At 100 millivolts, we are at 1.2%, and at 600 millivolts, the error is almost totally made up by the 0.5 percentage part of the spec. The error can be positive or negative. I decided to use the negative here in the plot because that seemed to be what happened in the real meter. And just to be clear, this is not something that is unique to the Crenova meter. All meters, even fancy bench multimeters, have the same issue, just the percentages and digit specs are lower. With that out of the way, I standardized on showing in an upper graph the complete measurement I did, while the lower one is the same graph but scaled to the specified error percentage limit of 0.5% in this case. From 400 volts, which was the highest value I tested, down to 10 millivolts, the meter comfortably meets its spec for DC voltage. Even at 1 millivolt, the error in my meter was just still usable 5% and not the 70% that could have been. AC volts is always quite a bit worse because the additional error caused by the AC to DC conversion. This meter, like most current meters, uses a true RMS conversion in software inside the chip. The lowest range is just 6 volts, and for at least the specified 1% accuracy, you better stay above 200 millivolts. But from then on, the accuracy of my meter was quite a bit better than the spec. Of note, the manual mindlessly repeats the 250 volts AC protection claim for the AC volt range, which is of course nonsense in this case, since the meter goes up to 600 volt AC. I always test how a meter behaves when both AC and DC are present, because not many meters pass this rather tough test. I'm using a square wave of about 19 volts peak to peak at 50 Hz with 50% duty cycle as shown by the meter on the right. True RMS meters will show this as AC with a voltage that should be VPP, and the Crenova does a good job at that. When I increase the duty cycle, the AC part becomes less and the DC part increases. Switching to DC, the Crenova shows the value, but it isn't terribly stable. This shows that within the processor the AC part is still somewhat influencing the DC. The point where most meters fail, and the Crenova is no exception, is when the AC and DC parts would fall into different ranges. So as soon as the DC part drops below 6 volts with the AC part above 6 volts, the Crenova auto range gets confused and it can't decide. That's very obvious to the user and therefore a lot better than other meters which display just nonsense numbers without any indication that something is wrong. Thanks to the manual range switch, it can be helped out of the dilemma, but the value should really be more stable. A second, more realistic scenario is that you want to measure a ripple AC on top of a large DC. Here I have set up a case of 60 volts DC with about 3.8 volts RMS ripple on top. While the Crenova has no issue with the DC, switching to AC shows 0. No ripple. This is again one of those cases where manual ranging is a necessity, because as soon as you do that, hey presto, there's the ripple. Worse is that if the DC voltage is a more moderate, about 21 volts, the Crenova starts showing something, but it's nonsense as manual ranging confirms. The Crenova is not alone in this behavior, and if you already own a multimeter, you may want to test the behavior of your meter with AC plus DC. The bandwidth for AC is specified as 40 Hz to 1 kHz, and I measured the -3 dB point to be just below 4 kHz. It did work quite well down to 20 Hz, and even at 10 Hz the drop was minimal. DC amps now. Note that the x-axis here is in milliamps, not amps. For anything above 20 microamps, the Crenova meets or exceeds its specification easily. I measured the resistance in the different ranges, and the values and corresponding burden voltages are in this table. They are quite standard values common for most multimeters. AC amps accuracy is surprisingly good, even at very low currents, thanks to the dedicated microamp range. The meter has no problems beating its specs very comfortably. In doing the amps verification, I must admit I'm not a fan of shared milliamp, microamp and voltage sockets. It's a good practice to get into the habit to always move the red lead when doing current and move it back afterwards. Even with the Crenova you have to do this for the 10 amp range, so not having to do it for microamp and milliamps is odd and will lead to many blown fuses, more so if you also own meters that have the traditional 4 inputs. For resistance, accuracy is surprisingly good, as long as it's over 10 ohms. Below that, the accuracy suffers. This is not a surprise, as the lowest value is 600 ohms, and the digit error is 5, meaning plus minus 0.5 ohms in that range. Lastly, capacity. The Crenova is again much better than its spec in the range that I verified, but I did not go to the max of 20 millifarad because I have no capacitors with such values. But as normal with multimeter capacitance measurements, it takes ages the larger the capacitor. These two here form 9200 microfarad together. It takes 15 seconds before we see a result. This is on par with other meters, and my only complaint is that there is no way to rel out the capacitance of the leads for very small caps. For frequency measurements, the manual says up to 10 MHz with 1 volt RMS for up to 100 kHz and 3 volts RMS beyond that. By the way, the manual is actually quite well done and comprehensive for a budget meter. In my test, it had no problems to go up to 8 MHz with just 1 volt RMS, and only after that I had to raise the input voltage. It finally gave up at 31 MHz, which is well beyond the specified 10 MHz. In diode mode, there's of course no problem measuring a single diode, but the Crenova does not use the beeper to indicate a conducting diode. 2 diodes in series are also possible. A red LED with about 1.8 volts forward voltage works. 2 red LEDs will light up, but the meter does not show the combined forward voltage. But the nearly 2.7 volts forward voltage of a white LED is still shown, which is relatively rare amongst multimeters. The leads that come with the meter are actually quite small and thin. You notice that when you put standard leads next to them. This is not necessarily bad, as it makes the whole thing more compact. The reason that they are smaller is that they are rated for just 10 amps 600 volts, while the normal leads are usually rated for 10 amps 1000 volts. Continuity test with the leads that came with it. It's pretty unresponsive, both on display and the beep. At least the beep is of tolerable volume, not earth-shattering loud. Swapping the leads for branded ones, I'm using Pomona, but others are available, shows that the sluggishness of the beeps is gone. Pretty much any budget meter is improved by replacing the leads with good ones. A drawback for this meter may be that the standard size probes are too thick to fit into the probe holders of the holster. The time for the meter to auto range is what I would expect. It's certainly not a speed champion, but not terribly either. The NCV function works quite well. The meter detected the live wire at about 4 cm or 1.5 inch distance. I'm not a fan of using NCV in multimeters because they are so bulky. If it's a tight space in a junction box with many wires, a voltage detection stick works better, at least for me. The live function works using the red lead. Although the manual doesn't say it, I think it's important for safety to unplug the black lead when you use the red one to plunge into live circuits, because the black lead may become live as well. It shouldn't, but anyway, the live detection works fine. Of course, I bet you also want to know what happens with the black wire during such a test. I connected it to the BM869S set to AC voltage, and the other connection of the BM869S is to earth. Interestingly, now that the black lead is connected to earth through the other meter, just touching the red wire triggers the live indication much stronger than before. And touching the red wire to a real live contact causes the Crenova to really go lively, and we have about 115 volts AC on the black wire. It turns out that in live mode there is a 10 megohm connection between the red and black leads, so the voltage I measured should be safe to touch, as it's just 25 microamps of current at 250 volts. How safe depends of course on the quality of the resistor, so I still think it's better to unplug the black lead for this function. And while we are on the topic of resistance, I measure the input resistance for other functions. This is where smart meters often have issues. It's 10 to 11 megohm for DC volts as expected. Same value for AC volts. You already saw the resistance for current modes earlier. The battery compartment is accessible by removing one screw into a metal threaded insert. The meter takes 2 AAA cells. Note that the orange holster goes around the screw. This means to take the holster off, you need to open the battery compartment first. To find out how much juice the Crenova takes from its batteries, I powered it through a bench power supply. The earning meter on the left shows the current and the primer in the middle the voltage. At 3 volts, the Crenova takes 1.8 milliamps. Turning the backlight on increases this to more than 13 milliamps. Common with many other meters, the beeper uses an enormous amount of current. The consumption is more than 30 milliamps when it sounds. And backlight plus beeper tops it at nearly 37 milliamps. I'm reducing the supply voltage while the Crenova is measuring a voltage. This is to see when the low battery warning will come on and if the accuracy changes at low battery. The low bat indicator shows at 2.48 volts. This makes this meter just marginally usable with rechargeable batteries that have a nominal voltage of 1.2 volts, so two of them have 2.4 through most of their charge. In the Crenova, the low bat indicator will come on early when the rechargeable batteries are still having a lot of their charge in them. Until then, the meter shows no degradation of accuracy, but shortly below 2.4 volts it starts to go astray and shuts down at about 2.2 volts. The meter has an automatic power off function which is on by default. You get a warning at 14 minutes and at 15 minutes the meter shuts down into a sleep mode using about 6.5 microamps of current from the battery. You can disable APO by holding func when turning the meter on. It will still beep annoyingly every 15 minutes. Opening the meter is not easy because that tight holster has to be peeled off. I can, however, say that it does get easier over time. Either the sleeve is becoming more flexible or I'm getting better at removing it. Once the thing is off, there are 4 self-tapper screws to be removed and the bottom shell can be lifted off. First impressions? As small as this meter is physically, it is still pretty empty inside. Not all that much to see. Of note, the rather large NCV antenna. No wondering that NCV is so sensitive. But of course, pinpointing one cable out of a bunch with an antenna this large is pretty much impossible. As expected, the underside of the PCB reveals no further components. A closer look at the input section. The 2 fuses are ceramic, both 5x20 mm in dimensions. The top one is rated 10 amps 250 volts and the lower one 600 milliamps 250 volts. Then we have the 3 current shunt resistors, the usual thick wire type for 10 amps, the 1 ohm for the milliamps and the 99 ohm for microamps. They go into a clamping network of large diodes. On the lower side you have a PTC, 2 5 megohm resistors in series to get a 10 megohm resistor with better voltage rating, and some transistor clamps, and that's basically it. The workhorse of the meter is a SD7501, which is a dedicated multimeter chip, with a whole bunch of mainly capacitors around it. A buzzer and crystal complete the circuit. Of note, there are pads marked TX and RX. The SD7501 datasheet has a suggested schematic, and while it's not exactly what my meter uses, it does have quite some resemblance in some areas. The chip could measure temperature as well, but that's not used here. The input circuit I showed earlier is here with a PTC and the transistor clamp. The 10 megohm resistor is here. Down here we have pretty much the same circuit the Crenova uses for currents. Interestingly, it recommends a 800 milliamp fuse instead of the 600 milliamps we have. Here is the 10 amp fuse and the wire shunt, and the 2 resistors for milliamps and microamps, followed by the diode clamp network. That strange thing here is a socket for measuring transistors, which the Crenova thankfully does not have, because accidentally touching the socket or something that's still left in there while measuring high voltage would be really dangerous. Below here are the buttons, and there's actually a button called rel/RS232, which sadly has not been implemented in the MS8233D. The RS232 and the RX-TX pads spotted earlier, and the schematic shows that this chip can indeed support a PC connection for data logging, but in my test with the scope I could not detect any signal. In meters with similar functions, one has to do a long press of rel to turn it on. I tried that using a needle probe and pulling the chip's pin 2 to ground, as with the rel button if it were there. The meter beeped, but otherwise nothing happened. Neither could I actually force a rel in ohms mode. My guess is this has somehow been disabled in the firmware. To wrap this review up, the tilting bail works of course, but on a wooden surface like my bench, the meter slides a lot. The good part is that the meter is so small, one-handed operation is still possible by using some of your fingers reaching around the meter to steady it while operating it with thumb and index finger. As with all meters, the Crenova MS8233D has some issues. It could do with a dedicated millivolt range, especially for AC volts. As demonstrated, if a source has both AC and DC, the meter struggles in auto range, but manual ranging resolves the problem. As with many meters, if you suspect a mixed signal, always use manual ranging. Sadly, the low battery indicator comes on too early to fully utilize rechargeable batteries. My final issue with the meter is that volts and milliamp microamps share the same input socket. I understand that there wasn't enough space for 4 sockets, but I still grumble. On the plus side, the small size and lightweight makes it very convenient to carry. The specs are quite reasonable for electronics work, and the meter meets and mostly exceeds them. True RMS, 6000 counts, and feature-wise, apart from rel, all the frequently used stuff is here. Safety and protection is basic but fair. The Cat3 600 volt rating is probably justified, but I would not use it for more than normal mains voltage of 240 volts and not in fuse boxes or similar high energy areas. The 2 sets of leads are actually quite useful, mainly because you can mix them, using a black lead with an alligator clip tied to a common ground and then using the red probe tip to do your tests. Simple but very convenient. All in all, not a bad choice for a multimeter, especially if the main focus is on electronics. If you like my videos, don't forget to subscribe. There are many more projects, repairs and reviews coming up, and it would be great if you decided supporting this channel by becoming a Patreon. Thanks for watching.